So last time we talked about conditions for on A such that we have at least one solution, and now we're going to talk about the condition such that if A satisfies it, then you have at most one solution. And this fact has a similar flavor to our previous fact, which was based on the rows of A. So this fact is that A augmented with B has at most one. It could have no solution, right? For any B, if and only if, we see that if and only if showing up again, the rank of A, we have this guy showing up again, is equal to the number of columns of A, and I'll say call A when I want columns of A. So now let's prove this fact, like we've done the last facts. So let's do the if condition, right? So the if part of this fact. So if the rank of A is equal to column of A, we want to show that, for any B, this has a solution. So if this is true, then each column of the reduced row echelon form of A has a pivot. That is true, right? So if the rank of A is equal to the number of columns of A, right? If we do the reduced row echelon form, we have exactly, since the rank is equal to the columns, we have exactly the number of rows that are non-zero as the columns, so we fill each column with a pivot, right? So what does that mean? That means that the reduced row echelon form looks like this. It has 1, 0, 0, 0, 0, 0. There has to be a 1 in this column because we have to have a pivot, and it's not on this row. 0, 0, 1, 0, 0. Right? It looks like that. So thus, there are no free variables. All variables are basic. Well, if there aren't any free variables and they're all basic, that means that all the variables are fixed if there's a solution. So all the xi's are fixed if there is a solution. Consequently, there is at most one solution for any B. So that's good. We got the if part, and that was pretty easy. So let's talk about the only if part. Well, again, we're going to apply the contrapositive. Right, so the contrapositive shows up again. And because of the contrapositive, and since the rank of A is less than or equal to the columns of A, if rank of A does not equal the columns of A, we have that the contrapositive, when we negate the equality, we have then that the rank of A is less than or equal to the columns of A. Right? So let's suppose that we augment. Suppose that B, the thing that we augment with, is just a bunch of zeros. Then AB is what we call the homogeneous system. Homogeneous system. So whenever we have whenever we have this happening, we'll get a homogeneous system. And when we do the reduced row echelon form of this guy, gives us a system with at least one free variable with a solution, at least one solution. So there's always a solution to the homogeneous system. You set all your variables equal to 0, and you're going to get one solution. That's why the homogeneous system is interesting. So so we have a system with at least one solution that has at least one free variable. And that's because the rank of A is, strictly less than the number of columns of A. Strictly less than, right? We know that rank of A has to be less than or equal to the columns of A. Since we're doing the contrapositive, rank of A does not equal the number of columns of A, so it has to be strictly less than. So that means that there's a column without a pivot, and that corresponds to a free variable. And we have at least one solution, so there are many solutions to A augmented with B, right? Which means that we've shown that if this is the case, right, if it's not the case, then we know that there is a B such that this doesn't have a solution, and we've demonstrated the contrapositive. That ends this proof.